Hi everyone. Today we're talking inverse tangent arctan. So in your notes, go ahead and label them inverse tangent arctan. I know that probably doesn't mean much to you, but we're going to talk a little bit about that. The first thing I would ask you if we were in class is, what does that word inverse mean? Maybe where have we heard it before? If you remember in Algebra 1, we used that term inverse when we talked about inverse operations to solve equations. Okay? So let's think about what's the inverse of addition? Well, the inverse of addition was subtraction. When we were solving equations and we had addition, to undo them we would subtract. The inverse of subtraction was addition. The inverse of multiplication was division. And the inverse of division was multiplication. Okay? We notice that inverses of an operation are the inverse to the other operation. And I know that that's really wordy, but what I mean is that inverse work in pairs, right? So the inverse of addition was subtraction, and the inverse of subtraction was addition. Additionally, multiplication and division, they worked in pairs also. Okay? This is a definition that's coming up. But the inverse of tangent is called, and you're going to really like this, it's just called inverse tangent, right? So we don't get fancy with it. But the inverse of tangent is called inverse tangent. Another term for it is arctan. I tend to use inverse tangent most of the time, but some books and additionally in some places, they refer to it as arctan. So I need you to understand that they're both the same thing. Arctan and inverse tangent are the exact same thing. Your calculator uses inverse tangent though. They use that tan to the minus 1. We can use this to help us find missing angles. Before, when we were using tangent, it was mostly to help us find side lengths. Now, we're going to work the opposite way, and we're going to work to find angles. Just from a symbolic side, I want to show you this. Let's assume that we have the tangent of an angle. We'll call that angle theta. Since inverse tangent is the inverse, if I apply inverse tangent to the tangent, they will cancel with each other. And what will be left for us is the angle. I know that the symbols don't really mean too much, but I'll write this out for you. If I apply inverse tangent to a tangent ratio, then the result will be the angle given, or the angle for that tangent ratio. That's a better way to say it. Let's see this with an example. Determine the degree of theta given the following image. Round your answer to the nearest tenth. Okay, so the first thing that I recognize is that I'm given a right triangle. Awesome. That means I can apply these tangent relations. And I'm solving for theta. I don't know what the degree is. I don't know what the angle is. So I'm most likely going to use inverse tangent. Well, what we already know is we know that the tangent of theta is equal to the opposite over adjacent. In this problem, the opposite over adjacent is going to be 13 over 45. I explained before that the inverse tangent of a tangent will just give me the angle. I can apply a substitution here since I already know that the tangent of theta is 13 over 45. So if I do the inverse tangent of 13 over 45, it should still give me what theta is equal to. I can take this part right here and I can plug that right into my calculator. So on your calculator, you're going to hit the second key, which is at the top left. So you'll hit second, and then you hit the tan key. So when you hit second tan, that's going to give you inverse tangent. If you'll see above the tangent key in blue, for my calculator at least, it says tan to the -1. Okay, so I hit second tan, and then I just simply put 13, then I hit the division key, 45. Since 13 over 45, we can simply say the same thing as 13 divided by 45. I close parentheses, hit enter. I got 16.113. However, the example asks us to round to the nearest tenth, so that would mean that theta is equal to 16.1 degrees. And that's your final answer, which makes sense. 16.1 degrees is a pretty small angle, and we know that our shortest side would need to be opposite to our shortest angle. And 13 is our shortest side, and it looks like it would be opposite to our shortest angle. So we definitely did that one correct. Let's do another example. Determine the degree of theta given the following image. Round your answer to the nearest tenth. In this problem, we know that the tangent of theta is going to be 17 over 22, since 17 is the opposite leg and 22 is the adjacent leg. If I apply the inverse tangent to 17 over 22, that should give me theta. So once again, I hit second tan, and I write 17 over 22, close parenthesis, and this time I got 37.694. But if I'm rounding to the nearest tenth, that would mean that theta is equal to 37.7 degrees. All right, team, that's your lesson for today. Hopefully you feel pretty good about that. If not, I'm still on the chat to help with you. You can now attempt the practice problems. I believe it's 20, or what is it? It's 11 through 20. Yeah, 11 through 20 on that sheet. Hope you're doing